Greetings everyone. Welcome to Datagaps webinar. I am Ritvi Sarangi, Growth Marketing Manager here at Datagaps, and I would like to thank you all for joining us today. The topic for today's webinar is Fix My Dashboard, Power BI Validation and Performance, wherein we explore how dashboard error occurs, like data mismatches across reports and sources, hidden issues that manual testing never catches, that can be solved before they reach the business users, and many more. We will also demonstrate how our product changes the game instantly by detecting performance bottlenecks before the user complains. During the session, you will see few poll questions appear on your screen. We encourage you to participate in those poll questions. If you have any questions, type them in the Q&A section. We will address those questions at the end. Joining us today on our panel, we have Pradeep Napa, Lead Solution Engineering, and Subhanshu Dikshit, Senior Solution Architect at Datagaps. With this, I hand it over to Pradeep and Subhanshu. The stage is all yours.
Thank you, Ritvi. Hello, everyone, and thank you for joining us today. It's a great to have you with us. If you have attended one of our webinars before, welcome back. So, if it is your first time joining us, so we are excited to hear you here and appreciate your taking the time to attend. So we'll start by discussing the challenges organization face in managing and maintaining the Power BI dashboards in production environment. So next, we will provide an overview of the data gap platform and the key capabilities that helps teams monitor, validate, and optimize their BI environments. Next, we will move into the live demonstrations where we will showcase the real all use cases and walk through the platform in actions. And finally, we will wrap up with the key takeaways, the recommendations, and next step, followed by your questions and discussions. So now we'll start why the business intelligence testing. So I would like to start with a common challenge that most organizations face today. Business users rely on every day to make decisions. However, there are three critical questions that where analytical team need to answer. Is the data correct? Is the dashboard performing well? Is the dashboard working as expected? Unfortunately, many organizations only discover the use issues after a business report user report them. So today's demo will show how we can move from reactive troubleshooting to the proactive monitoring by continuously observing the dashboard health across the data, the performance, and the reliability. So let's start with the data observability. So a dashboard may load successfully and perform well, but that doesn't necessarily mean that the data is correct. Every day, the data refreshes can introduce a new issues such as a missing record, a schema changes, a delayed refreshes, or unexpected KPI variations. So these issues often got unnoticed until a business user questions the number. So with data observability, we continuously monitor the data freshness, the schema drift, KPI integrity, and the data anomalies. So this helps organization to detect the issues before impact the business decisions. So the results is increased by trust in the analyticals and reduce the manual validation efforts. Okay. So by taking a simple example, imagine. So yesterday's sales were shown like a 10 million and today's they suddenly dropped to the 5 million because half the records did not load. So the dashboard works perfectly, but the data is wrong. That's why the data observability helps here. I'll go to the quick demo. Okay. So now let's look at the data observability in action. Think of this as an automated monitoring pipeline that continuously validates the health and quality of the data being displayed in the Power BI dashboard. So this pipeline consists of three key stages: the Power BI extraction, the data preparation layer, and the observability engine. Together, these components provide an end-to-end automated monitoring of a dashboard data. If you look at the Power BI, you can see the report which will be loading. Okay, so this is the Power BI report, and now you can see the data being extracted directly from the report. In this example, we are monitoring one of the visual and capturing the underlying data set for validations. Next, the data passes through the preparation layer. So here, the attributes are standardized and transformed where required. For example, the date fields are converted into a consistent format, while other fields pass through unchanged. So now the next step, the data prepared is sent to the observability engine. This is where the intelligence comes in. So if you look at the configurations, you can see the group by column is set to the country, and the measure is configured as a sum of confirmed cases. And let's move to the prediction section. So here we are using the time series prediction. This is one kind of method with, with a daily monitoring frequency, and the minimum data points required is set to 3. So this means the system first observes and learn from the previous 3 days of historical data. Once the minimum number of data points is available, the model begins generating the prediction of the future runs. Now let's review the results. Here you can see the two anomalies were detected. The values for the USA and India fails outside the expected historical range, and we are automatically flagged. To better understand why, we can look at the trend visualization. Okay, so here the shaded prediction band represents the expected range based on the historical behavior. For 7 days, the actual value remained within the expected boundaries. However, on April 30, the metric suddenly spiked far beyond the predicted range. As a new data arrives each day, the values are compared against the predicted range. If a value fails outside the expected range, it is identified as a potential anomaly. Most importantly, this happened before a business user noticed incorrect data in the dashboard. That's the value of the data observability. So coming to the next one, the dashboard performance monitoring, the optimization. So normally a dashboard that performs well in development may behave very differently in production because due to a larger data set, a more users, or a complex calculation. So we monitor a dashboard load times, a query execution, a visual rendering, and schematic model performance. So beyond identifying the slow dashboards, we also help understand the root cause and provide the optimization recommendation, such as improving aggregation, optimizing DAX, or finding unnecessary columns. So this ensure the dashboard remain fast and responsive as the data volume grows. We'll go with a simple example. A sales dashboard that loads in 3 seconds today may take a 20 seconds 6 months later because the data volume has doubled. So the performance monitoring helps identifying the trend and recommend the optimization before the user complains. Quickly we'll see the demo for that. Okay. So in this example, so we have configured a monitoring for multiple Power BI reports. For each report, we collected a key performance metrics such as report load time and execution status. So here you can see the load time being captured for the different reports. For some reports, the load time within 3 to 5 seconds, while the other may take longer depending on the complexity of the report and the underlying data model. So the collected performance data is sent to the next level, that is we call as a observability engine. So within observability engine, we group the data by report or the page name and monitor the report load time over the time. And if you go to the prediction, for anomaly detection, we are using a time series model. The system continuously learns the historical performance pattern and calculates the expected range for the future executions. So based on the configuration monitoring, the frequency daily, a weekly, or a yearly, the model predicts the expected report load time and establishes the upper and the lower performance threshold. Now look at the results. Most reports are performing within the expected range. Therefore, therefore all validations are passed. So in addition to the anomaly detection, so we have also configured the business rule for the performance testing. Okay, so here you can see the two rules so that we have created. So the first one, that rule validates the report load time. Example, if I go through it, we'll see here rules. Okay. Okay. So this rule validates the report load time. In this example, we have defined a threshold of 10 seconds. Any report that takes longer than 10 seconds to load is automatically marked as failed. So now let's look at the results. However, one report is taking approximately 145 seconds to load, significantly exceeding the configuration threshold. As a result, that monitoring job identifies it is a performance anomaly. So once the performance anomalies are identified, the results can be automatically distributed through the email notification. Here we can see it. And integrated into the existing operational workflow for the investigation and remediation. So here the key benefit is that the organization gains the continuous visibility into a dashboard performance and can proactively address the performance degradation before the business user experiences slowness or the unresponsive reports. We'll quickly see this third use case. So this is about the dashboard error monitoring and reliability. This is the third area. So normally in a production dashboard can fail for many reasons. A refresh failure, a query timeouts, or schema changes, or the broken measures, or the visual rendering issues. So in many organizations, the first indicator of a problem comes from a business user saying that my dashboard is not working. We are continuously monitor dashboard health and detect the broken visuals, track the refresh failures, and identify the schema drift and provide the root cause information. So this helps team to resolve faster and improve overall the dashboard reliability. For example, in this case, suppose a source column get deleted. The dashboard opens, but one of the visual becomes blank and displays an error message. Instead of waiting for a user to report it, the monitoring system immediately alerts the team and identify the affected report and visuals. I can quickly show that an example. Suppose there a Power BI report if I open. So the report will look like this. When you open it, it automatically failed for some regions. Right? So as I discussed earlier, we created the two rules, one for the load time and the second for the report one. So this rule validates the report health and status if the report contains the failed visuals or the rendering issues. The monitoring job flags the report as unhealthy and it identifies. And if you go to the result section, if you click on the report section, so here you can see it, right? So for all these runs, when the report opens, so that time automatic the visuals are already in the a failed state. So we automatically get if anomalies as in a failed state. So this is about the three cases. So I will hand over to the Shubhanshu for the remaining one. Over to you, Shubhanshu.
Hi, can you guys hear me?
Yeah.
Yes, all right. So let me start with the second part of today's demonstration. So you've kindly, just to recap, what we have seen so far are a good chunk of use cases which the team has provided. And again, all of these are with regards to performance. I would like to add on a few set of important use cases that we also want to look into. The first use case I want to discuss is lineage. Now, you might be surprised to hear lineage in a Power BI centric demo, because usually you have lineage in terms of understanding the and tracing the actual data sets and columns moving from one system to another. So you have your, say, bronze, silver, gold, or staging, mart, and intermediate layers. But I'm happy to report that using BI Validator, the application can now connect to the semantic model as well as the underlying reports. And more importantly, we can now figure out automatically using the definitions themselves if a particular data model or a particular, in this case, column is affecting certain measures as certain reports in another system. This kind of impact defining is very helpful for an end user in understanding exactly what might be going wrong. So earlier there was an example that if there's a column that's changing or if there's a column that's updated, certain reports might not be working. And yes, the application is going to catch the visuals not working in that scenario. However, with the lineage system, you can now trace and understand exactly which specific visuals and reports are having these issues. More importantly, because we can keep track of measure definitions and measure, say, calculations specifically, we can now ensure that if there is a change from the expected measure or calculated column, we can alert the end user. Meaning that for some reason, if for a particular hot fix or for any discernible reason, a single developer updates one particular measure definition or a calculated column, that impact is assessed and informed to the rest of the team. That way, after the hot fix is done, folks know exactly which corresponding column and data model table to change and update to make sure that the reports are working as intended. So, lineage tracking becomes a very important use case for our team. I'd like to return to basics in terms of another important use case, which is finding out if visuals are not loading in correctly. So this is a very simple example of what we saw earlier, where if visuals are not loading in correctly, the application can call out issues. But apart from this, an important aspect, and this is a repeat from our previous demos, is visual validation and report validation. So previously, in a lot of demos and other content that you might have seen on YouTube, you might have seen reports like these, where our problem statement is to ensure that the numbers we see within our reports, now these could be KPIs, these could be tooltips, this could be numbers hidden within tables on a particular chart. We would like to make sure that the numbers here are valid. So historically, what we've been doing is this particular use case, which is comparing it against a source of truth. Now, in this example, you see our source of truth is created by a combination of multiple tables or multiple columns. And this is what we want our application to compare against. And so if there is a mismatch, the application calls it out. In this case, we see everything is matching as expected. And this is the problem statement I want to focus in on. These values can still be incorrect. Remember, we're talking about observability at this point. So what we have added on top here is a use case of anomaly detection. This is what we were seeing earlier, except instead of looking at the loading times, we'll be using the same principle to look at the actual values itself. So here you see we have a few set of values, and these are subject to time changing, meaning that as seasons come and go, these patterns rise and fall in certainly unexpected manner. So the application understands that. Similar to the loading times, we feed in the actual values itself, and then we can call out anomalies present in this particular system. Now you have seen anomalies already, but what if you want to deploy something a bit more complex? Here, you'll see one of the key distinguishers, or the way reason our application is very prominent, especially amongst our competitors. It's because our application allows for customization and integration of a lot of different kinds. Here, you see that we have basically enabled a fraud detection system, and we have done this using a simple plugin. Plugins are customizable portions of the application. We can basically extend the product to go with the requirement that you have. So in this example, we're going with fraud detection. Your example can be different in another case as well. And so we'll provide a proper front end so that non-technical personnel can still use this customization. And at the end of the day, the application calls out anomalies present in the actual data set. This is another way the application can catch problems within your system. Now, moving forward in another aspect, because we look at the data model inherently, we have access to analyze and assess the data model. So let's go through what we have actually captured here. As you can see, we have plugged a BI report into our analyzer system. This is a very simple report, so we have hardly a couple of pages here, but it goes to show what we are trying to associate. Firstly, we're trying to see how many tables we are working with, what are the relations, what are the missing relations, and most importantly, how many columns are being unused. When you're dealing with Power BI reports, an important factor to understand is that if you have a particular data set and it has 30 columns, if you're using just 5 columns amongst them, the 30 columns are still being loaded in. This is what's going to affect your memory. So here, if I go into, say, the columns, you'll see that there's cardinality present right here. This is the memory being used by each of the corresponding data sets. So if you're not using that, that's being used nevertheless. The same thing is true for relations. These relations are being built in, and the application is still using them as per the requirements. So it's very important for us to understand what are the unused systems, and well, you need to discard them in a lot of scenarios. Because if you don't, the application will tell you at which particular page there are problems coming in. This is one of the best screens that the application has to offer, because here we tell you at a visual level exactly how long a particular column takes to load in and what are the different measure definitions that we are trying to work with here. In fact, there's also a link to the actual report so that the end user can understand that, hey, this is the report that we are trying to deal with, And of course, these are the actual visuals associated with it. Now, another thing I want to focus in on real quick is the end-to-end factor of our application. So previously we have discussed report to data compare, which is basically the top half of this particular diagram, the first three nodes, where we can compare data sets or files against our BI reports and numbers. Well, firstly, there's an important caveat. We can, if we want to, include data model validations here as well. That is what this tax query node is for. However, the use case I want to focus in on is end-to-end validation. There's a lot of scenarios where BI teams might not have access to these particular underlying data sets. However, if you do have access to it, or if you're looking for an end-to-end solution, which is what we would like to offer, you can connect to the underlying raw files, the underlying databases, as well as the BI report, and ensure that you can keep track of these metrics moving downwards. So here you will see the metric we are keeping track of is this particular system where we're keeping track of the classifications and other aspects. When I go into my golden level measure, I use my generative AI system to basically recreate the table for me. In this case, since we are working with this particular target model or the golden layer model, the application uses those tables to create the aggregated source of truth. And so when we compare source and target, we see that there are missing records, but whatever is present is matching perfectly. All right, so you can think that, yes, this is perfectly fine. Everything is looking good. However, if I apply the exact same prompt to my silver layer, you'll see that the application comes out with a different query because obviously they're using different tables right here. Now, when we compare golden and silver, we see that, hey, there's a bit more of an issue present. The numbers and flags are not really working as expected. In fact, there are extra records present in the golden layer which are not supposed to be present. This usually comes in because there are left joins present where there should have been inner joins. And so now we have found out that the data in the golden layer itself was incorrect. And this exact same process can be done one step further down between bronze and silver. So in this example, we see that the records between bronze and silver itself were incorrect. In fact, there are some records present in the bronze layer which have not been successfully transferred into the silver layer. And that's another facet where the application comes in. So let's kind of summarize everything together for us. I'm going to close these notes and let's open up the actual use case itself. So I'm going to open up a different container, and just as a tidbit, containers are basically logical isolators. So if you have different projects and different users need to have different conditional accesses to them, that's where you apply containers. Now, I'm going to open up a report test plan right here. A report test plan is basically a test plan summarized at a report level. Let me open up and show you the same. There we go. So the important facet of a report test plan is that we summarize all the different test cases that you have associated with a single report into one consolidated view. Because at a broader scope, when you're creating test cases, you are not going to be creating test cases individually. You're going to be creating test cases in bulk. To help you with this, we have generate functions. This is what it does. You basically define what type of BI data flows you would like to generate, and you can generate a ton of test cases in bulk. So let's summarize. What have we discussed? We have discussed visual validation. We're basically ensuring that the visuals are loading in. If the visuals are loading in, we're making sure they are correct in terms of data as well as in terms of pattern recognition. We're making sure the visuals are loading in within the expected time. We're making sure that the measure definitions are working as expected, or the calculated columns are as expected. If there is a change, we are highlighting that, and we're also telling you in the lineage form which reports and data model tables are affected because of that change. But now that we are doing all these many things across so many reports, how am I actually keeping track of all of these different changes? Well, that is once again the reason we are showcasing report test plan. You just have to add the reports from the workspaces that you're dealing with. The application will automatically find the test cases to which these reports are associated with. Then, as a summary run, what we give out is firstly a summary at an overall report level. In this example, there are 11 reports. Out of the 11 reports, 8 of them have failures associated with them. All right. I can look into a particular report and understand exactly what's going wrong in this scenario. For example, when I did a regression check, So a regression check here is ensuring that the reports are comparable between, say, source and target. So in this case, it's basically making sure that after a particular update, the reports are having the exact same values and are visually identical. So yes, the application has checked that. So visually, everything seems to be perfectly fine. However, there's a bigger problem here. The reports are no longer in sync with the databases. So here, when I compared this report against a database, we see that there are problems coming in. The numbers in the database are not matching the numbers in our report. And so you can understand as an end user, when I look at this summary, I can have a bird's eye view. I can understand exactly which reports I want to focus in on. In fact, I can just filter on that directly. So I can just go ahead into go ahead and apply failed. And so now instead of looking at, say, 500 reports where there are only 6 failures, I don't have to filter through everything. The application does all of that for me. Another thing that the application does for you is that we are going to automatically generate reports. So whenever a particular test case is executed, so here let's open up, say, DIM customer CSV itself. You see we have this corresponding report generated. This is basically a report. You can go in and you can customize this report as per your requirements. That is why we have widgets within this particular scenario. And again, all of this is there to ensure that the reporting section that your end user sees is tailored to the experience that you're looking for. Because while the application can always automatically generate reports, as we do, we understand that one of the main use cases that the end user is looking for is to have a proper bird's eye view, to understand at a distance exactly the overall health of your report. And then if you want to, you would want to zoom in and understand exactly where things are going wrong. Since we have some time left, I also want to discuss a very important use case in terms of measure definitions. So let me open up that specifically. So I'm using measure definition as it's a Tableau-centric word, but the exact same word within Power BI will be the measure column or the calculated column. I would like to use this time to show you that while we can actually look at these lineages, this is how we can connect directly with the expressions of calculated columns itself. Now, the example that we're looking for here is an example that a client had asked for, which is they wanted to ensure that there are no hard-coded values within their measure and calculated columns. Now, you'll see the reason I'm showcasing this is to tell you that we have access to these values inherently. Now, in this example, we would like to check for hard-coded values. But in our original example, we would like to benchmark this and check it against its own previous version. This is what the previous example was about. If somebody is altering this particular expression, you would want to know what the original expression was. You would also want to know if this has been altered, what the impact of that is. So that's where the application comes in with its meta report elements. But data model definitions are just one part of the story. There could be use cases where you want to do this exact check, except you want to apply it to a different element of a report. You can think of it as font, alignment, the color schemes, or visual position itself. The application has access to all of this information as well. So if you want to, you can define use cases along those fronts. So at the end of the day, what we really want to do is we want to ensure that if there are any issues in your reports, be it in terms of your data model definition, be it in terms of the data model values, be it in terms of ensuring that your filters are working, that your values are correct in comparison to your data sets, in comparison to the patterns, or to ensure that your reports are optimized and are working as expected, the application provides these use cases. Now, let's finish up this particular demo. The last thing I want to focus in on is a stress test plan. So this is one of our kind of final use cases. So let's open up stress test plan. Now here, you'll see what we are trying to achieve. Let me first go into run options to tell you what we are trying to showcase. So the problem statement here is that, sure, we are trying to optimize our reports and we're trying to make everything work as expected. But the problem statement here is that I know that on Monday morning at 10 a.m., there are going to be 500 users accessing the reports all at once. Now, again, that's the problem statement that I've just built up for myself. And I know that my premium capacity might not be able to handle it. Now, I made sure that the reports are correct, but I have not really checked it for all 500 users as well. Now, that's an important distinction, because when I'm executing these reports or when I'm executing these test cases, I might be doing this via a service principal or via impersonation of a couple of users. But the problem statement here is much broader. I want to make sure my reports are correct, but more importantly, My reports should be correct for each and every user who I know is going to access these reports. So that's where stress test plays a dual role. You can define 500 users specifically by giving the list of the users we want to impersonate. So basically define that these are the, say, 400 users you're going to work with. You give the list of those as well. Then you define what the overall pattern is that you're looking for. Like, for example, 0 to 500 in how much time? You can say that within 2 minutes, all 500 users are going to be logging in all at once. That's what this ramp up time is really for. These reports are highly complicated. So I know that if somebody is looking into a particular report, they'll be looking at it for at least 2 minutes. So I define the think time of an average of 2 minutes. This entire process is going to go on for a good amount of time. So I just define 6,000 seconds as my expected time. Again, I can increase it and decrease it as per my requirements. Now, as 500 users are going to log in, you understand that the premium capacity might take some time to scale up. And while this happens, you can simply say that certain users might not be getting the reports loaded in. So what do they see? Well, they see a timeout error. Basically, they see that the reports are not loading in. Or they wait for 60 seconds and then they click F5. This user interaction is very important for us to simulate, because the way BI servers work is that if a BI server has 300 pending requests and 100 users just click F5, now the BI server has 400 pending requests. Sure, there are algorithms and there are applications which are built to make sure this does not happen. But in our practice, we have seen that BI servers usually treat these new requests as brand new requests. They don't check it against existing requests. And so what this results in is a detriment to the overall performance. So that's why this is important for us to simulate. Now, SLA is basically your expected loading time. So if anything takes more than 15 seconds to load, be it a filter or a report, you want that flagged. And the reason screenshot sample percentage comes into play is because user list can be distinct. So this user list is completely optional. You can simulate the same user 500 times and run this entire test purely as a performance test. But remember, we want to make sure that our reports are loading in for all users in an appropriate fashion. So if you're doing this and something fails, like say there is an error, there's a 401 error, there's a forbidden error, we want to know that. So yes, the application will tell you there's a forbidden error. But what's better than just an error node? A screenshot. So that's where the screenshot sample percentage really comes in. You want this at 100 if the use case you're looking for is auditing, where you want to ensure that for every user, every filter combination across all pages is accounted for. So in those scenarios, keep it at 100. In other scenarios, well, you can get by at 20% as well. Refresh time comes in as another use case. Now, refresh time is basically how fast are these results going to be coming back when you're doing this live. Now, this isn't really needed for, say, overall batch processes, but if you're monitoring your resources in parallel, that's an important metric. And the last one is filter combinations per page. So the reason there's a limit for this is quite straightforward. In production grade reports, you might have, say, 16 values for every filter and 6 such filters. So with quick math about with some permutation and combination, you know that these numbers can reach upwards of 10,000 very fast, very easily. And so if you're applying all those permutation and combinations, well, firstly, it's not realistic for people to apply all of those combinations. So if you want to stick to the real stuff, you can say that, okay, people are going to apply, say, maybe 15 permutation and combinations, and you can be good to go. So all of this is what is configured. And in the end result, the application runs a stress test. And this tells you specifically what are the average open times for a report, the average filter time application, the P50 and P90. Basically, these are statistical methods to tell you the average times. Again, the mean might not be as helpful. And within a particular report, you can open up and see exactly what we did. Did we apply a filter? Did we open up a system? And you'll see we have screenshots associated for all of them in line. And all of this information can be exported towards the end user. You can even see what the filter combinations were that were applied right here. So why did we spend so much time on stress test? Well, it's because we are trying to answer the overall question, which is, hey, just fix my dashboards and just tell me if something is wrong. Because at the end of the day, the product capabilities are pretty well known, and you'll see a lot of content around that. Yes, we validate numbers, we validate filter application, we validate the overall optimization, we validate the visuals, we validate a lot of metadata as well. But what we want to focus in on today is to show a message that, well, even if you have, say, 500 reports working within your system, we have tools to ensure that the visuals are loading in, that the data sets are working properly. All the things I repeated earlier, but more importantly, you can apply this across different users and different filter combinations as well. This is the most thorough experience that you will get with regards to QA. And that is the reason a lot of our clientele use our application with the thoroughness in mind. They have RFPs where they have to ensure that 100% validation is being achieved, that every filter combination is accounted for all the users. Doing anything like this with any kind of script is very difficult, and manual intervention is completely out of the picture. So the overall messaging that we want to put today is that at the end of the day, our application can be defined once. Basically, you deploy it in one scenario, and then you can execute these test cases in an automated scenario. The moment you update something in production, this can be directly called as part of your CI/CD. Not just that, we have schedulers, we have external integrations, connections, and if something fails, don't worry, you don't even have to log into the application. The application can automatically send out these reports to you. There can be tickets raised, there can be ServiceNow incidents raised, you can connect to Azure DevOps, and at the end, of course, the most rudimentary one is email notifications sent out in the customized templates that you're looking for. So all in all, as you can imagine, there's a lot that we can do. And if there are any questions with regards to a specific feature, with regards to a specific scale, or a pain point that your team has faced that we might not have discussed today, or that you might want to discuss in more detail, you need to get in touch with us so that we can do a proper demo on that front. All right. So let's finish up this particular use case. Let's go to conclusions. Let me just open up the slide and we can bring up if there are any questions left out. So let's bring up this particular slide. All right. So now that we have finished this up, are there any questions that we want to answer?
Thank you, Suvanshu. Thank you, Pradeep, for this insightful session and for showing us the practical walkthrough. There are a couple of questions that has popped up. Let me go through it. Okay. So what are the top factors that typically slow down a Power BI report?
Pradeep, you want to take this one? Or should I take it?
Yeah, sure. So basically the large data set and the complex DAX calculations and any insufficient the data models are the most common causes of the slow reports. And also if there is any too many visuals and slow queries can also impact the performance.
Great. Good to know that. Our second question would be, how do teams typically find out that the reports are broken?
Well, at the end of the day, if you're not using a product like ours, it's the end users who are going to kind of say upfront that, hey, these reports are incorrect. And that is why our application comes into play. That's how most users actually find out. There are solutions which try to use response codes and simple scripts to associate this, but they do not provide the level of detail that our application provides, as you saw with the demo, the screenshots and everything else. So most users are going to find out when they actually open up the report, when they actually apply filters. If you're using an application like ours, you'll be notified well in advance that certain reports are broken, say for certain filters as well.
Great. Good to know that. My third question would be, what are the quick fixes team can apply after using a BI analyzer?
Well, the BI analyzer is going to tell you specifically three important aspects. The first one is going to be with regards to the unused systems and everything that's going to slow you down. It's very similar to what Pradeep had answered a while back. The BI analyzer is going to tell you how many unused columns you're dealing with. That's dead weight. How many unchecked columns or joins are working with. Those are broken joins. Those are going to cause problems in your reports. Not strictly an optimization, but your numbers could still be incorrect. So as soon as you use the analyzer, understand how much dead weight you have, how many unused columns and unused data sets you're dealing with. Remove them from the data model and you'll see an immediate gain in your overall reports. Furthermore, you can look at specific visuals and look at the loading times of those visuals to then specifically tell if something is going wrong for those reports or specifically for those visuals itself.
Good to know that. And we'll take one final question, and that would be, how do frequent schema changes impact reports?
Yeah, that's a very good one. And it actually comes in from an end-to-end perspective. And that's where the lineage is something we focused in on at the very start of my section of the demo. which is if there are schema changes, the effect can be everything from pipeline breaking to very silent but very dangerous error that comes into play. So let's give a few examples, right? Let's say there's a data type change where a float value has been changed. Float values are basically decimals, and let's say you're working with a financial system. So instead of working with, say, 4 significant digits, you're working with 8 significant digits, or maybe 6, or maybe you've reduced it. Now, this is a particularly dangerous use case because what this affects are the actual values. This is not going to break the pipeline. You see, if the data type was changed into a string, there's a good chance that the data type, my pipeline might simply break. And your rules will catch something that, hey, we are seeing null values here, we are seeing strings here, something is off. But if the change is much more minute in nature, the numbers are going to change. And when you're aggregating with these kind of values, with these kind of significant digits coming into play, your numbers are not going to match your expected value. So when you change the schema, your values are definitely affected. And the biggest problem here is knowing the impact of this problem. So if something is changed in your original column, think of a revenue column. Now, this is a very primary column, and this might be used in 20 reports. If there is a schema change here, this is now affecting 20 reports, it's affecting, say, 30 data models. How are you keeping track of it? So the danger can be catastrophic depending on your system. And if the change is minute, well, your values might be incorrect for months before anyone even notices that, hey, we were expecting rounding values in this fashion, and we're not actually doing the rounding as expected. So I'd say that schema changes, if it's very good that your pipeline breaks after a schema change, because at least you're finding out the issue. But schema changes many times go silently, and these are the worst kind because your values are incorrect in a lot of scenarios, and you are not even aware because your pipeline is not breaking. So yeah, a lot to say about schema change, and that's the main reason our application has brought up the lineage field so that we know exactly how far the impact of these issues are within your data model and within your reports.
Okay, thank you, Subhanshu. We will follow up on any remaining question from the Q&A section by email. Once again, thank you everyone for taking your time and attending this webinar. If you want any of your questions specifically answered, or if you have any requirement which you believe we can help you with, please do reach us at contact@datagaps.com. And you can request a free demo by clicking on the button that is on the corner bottom right side of your screen. So yeah, that's about it. Thank you so much for attending our webinar. Have a great day.
Thank you.
For further questions, feel free to reach contact@datagaps.com. Scan the below QR code for free demo. Thank you.